Okay, looking now at the part D of question 1. Draw the configuration of these capacitors that will store the most charge. The most charge that we can store is if we place them all in parallel, then we'll be able to pull more charge off with the same voltage. So it's C parallel is equal to C1 plus C2 plus C3. And the way that we can draw that configuration is like this. And then those are our three capacitors. If we connect them like that, then we'll be able to, if we put a battery here, you don't need to draw this in to get the marks, but if we put a battery here, we'll be able to pull lots and lots of electrons off the top plates and put them on the other side. So to increase the capacitance with multiple capacitors, we need to place them in parallel. Okay, and then we have a 48.3 nanofarad and a 2300 picofarad capacitor given to Hannah in parallel, connected like this to the 1.7 microfarad capacitor. Calculate the capacitance of this configuration. Okay, the key here is to first work out what the parallel bit is, and then to add the two as if they were in series. So the capacitance of the parallel bit is equal to, well, that's just going to be the sum of the two, because that's how we add them in parallel. It's going to be 48.3 times 10 to the negative 9. That looks like a 7. Plus 2300 times 10 to the negative 12. That's a 2. That's the parallel bit. So that is equal to, if we go to our calculator, it's 48.3 times 10 to the negative 9. Plus 2300 times 10 to the negative 12 is equal to 506. I really want this in standard form. So 1, 2, 3, 4, 5, 6, 7, 8. It's 5.06 times 10 to the negative 8. Farads. Okay, that's the parallel bit. Now we need to add the two bits as if they were in series, and when we add in series, then we need to use the inverse. So C total is going to be equal to the inverse of 1 over C parallel plus 1 over 1.7 times 10 to the negative 6. All inverse. Which gives us, okay, now we want, actually let's just clear everything. We want 1 over 5.06 times 10 to the power of negative 8 plus 1 over 1.7 times 10 to the negative 6, closed bracket, and then we want an inverse, which we can do by taking this. So we get 4.91 times 10 to the negative 8.